Good evening, everyone, and welcome to the Amateur Radio Technician class, session number 13. During our previous session, we had a review of our curriculum progress. We talked about the practice exams. We also dealt with power supplies, the concept of voltage drop. We went into digital modes and interfacing. We discussed ferrite chokes. We also looked at RF grounding, then mobile power sources. We talked about features such as microphone gain, VFOs, as well as keypads on radios, and other features such as memory channels, scan, squelch, repeater offsets. Then we went into what digital voice hotspots were, as well as modes such as DMR and D-Star. Then we discussed filters, as well as the RIT or clarifier, and we ended the theory with PTT. And then we went straight into our usual question pool review. So our agenda for this evening, we will again have a look at where we are in the curriculum. We'll talk again quickly about our practice exams. Then we go into the technical topics such as transceivers, what are transverters, as well as RF power amplifiers. We discuss the concepts of sensitivity as well as selectivity. Then we go into different circuits such as preamplifiers, mixers, oscillators, modulation. We discuss radio frequency interference and some concepts such as fundamental overload harmonics. We'll also discuss what we can do to resolve interference issues. Then we go into some test equipment such as multimeter, what's a voltmeter, ohmmeter, ammeter, and then we will end with solder. And then we will do our usual question pool review and then announce the date for our next session. So just quickly, this is our curriculum, and you can see we have progressed quite nicely, and we are onto the topic station equipment. So we will start that topic this evening, and we will also aim to complete this topic. So if you look back at all of the topics we have covered, it's quite a lot. So very well done to all participants for staying the course and absorbing all of this content. All right. So just a usual reminder that it's never too early to take practice exams, and we also take the opportunity to congratulate all those who have sat, passed the exams, and have also obtained the amateur radio licenses. Very well done. Okay, so the book that we're using, the No Nonsense Technician Class License Study Guide. All right, so let's just, again, we like to do a reality check. What are we talking about? Amateur radio, and we don't want to lose sight of, while we're going through all of this theory and procedures and information, what are we really trying to achieve, right? So as an amateur radio operator, this might be a station that we will eventually acquire once we have gotten our license, So we always just like to keep it real, and this is what we are working towards, or some version of this perhaps. There are so many options in amateur radio, but this may be one of them, and this is an HF amateur radio station. And you'll see where all of these little pieces fit in towards either setting up, operating, troubleshooting, avoiding interference, all of those things are towards operating an amateur radio station. And one day, probably we all hope to achieve setting something like this up at our home or some other location. All right, so let's go straight into some of the technical topics this evening. And quite a bit of what we share on the courses, the course content, not directly in your exam, but it's related, and we like to give a bit of extra information. So we want to talk a bit about transceivers. Now, this is a term we would have bandied about throughout the entire course. We're talking about HF transceiver, UHF, VHF transceiver, and so on. But, what exactly is a transceiver? And we will come to a slide just now that breaks it down to the exam question. But we have a bit of extra information here in terms of a definition on your screen. We would not go into detail in it, so you can read this on your own when you get the slide deck. So have a look at this. Let's go to the next slide. Right. So a transceiver is simply a concatenation of two words, transmitter and receiver, right? So it just adds the two words together and leaves out some letters in between. So if it's a transmitter and a receiver, you might ask yourself, well, how come a transceiver? Well, back in the earlier days of amateur radio, a transmitter used to be a separate device and a receiver used to be a separate device. It was not unusual to have them as separate devices. In today's world, with miniaturization and the electronics that we do have, very large-scale integration, microprocessors, and all sorts of miniaturization of electronic components, where we move from vacuum tubes to solid-state electronics, we are able to combine, the manufacturers are able to combine the two. So you have a transmitter and a receiver, and that's how we get the word transceiver. So on your screen, we have what an HF transceiver looks like and what a VHF, UHF transceiver might look like. Of course, many form factors, different services and so on, but just to give you an idea what it might look like in terms of the equipment. These are just block diagrams that show the various stages of a transmitter and a receiver. So this is just really extra information or a little more advanced information for your general knowledge. If you'd like to look at it, what are the stages of a transmitter? What are the stages of a receiver? You can look this over. But for the exam, what we need to know is that a transceiver is a device that combines both a receiver and a transmitter. So again, it's a concatenation of the word of transmitter plus receiver, and that's how we get transceiver. Exam question. Right, a little bit of an oddball here. So we have another term. Again, this is a slide we will not go through in any detail, but it provides some additional information that you can probably take a look at. It will give you a bit more information than we actually require for the exam. And we are talking now about a device known as a transverter. So probably as an unusual term, we're probably accustomed to transmitter, and then we have introduced transceiver, but we are now talking about a transverter. But exactly what is a transverter? So let's come to the next slide to illustrate. All right, so a transverter, remember a transceiver we use to connect our antenna usually, and it's maybe an HR transceiver, and we'll be talking on HF frequencies. But what if we want to use that same rig or that same device to operate on a different band other than HF? Maybe we might want to operate on the VHF band or maybe the UHF band with the same transceiver. Can we do that? Well, natively, no, because the transceiver only supports HF. And you remember that HF generally is between 3 megahertz and 30 megahertz, right? That's why we keep repeating that trusty slide that shows what is HF, VHF, UHF, and so on, right? So this is an HF transceiver, so it's not able to do VHF or UHF natively. But if we were to add an accessory device called a transverter, then we are able to access other frequencies using the same transceiver. And what a transverter is really is a converter device. So while our transceiver only speaks HF frequencies, we're able to get on and operate on the VHF and maybe the UHF band according to the specifications of this device called the transverter. So we put it in between the antenna and the radio, and while natively this radio may only do HF, we can do VHF on it by employing a transverter, and the transverter essentially converts. So it will take the HF frequency that we are transmitting on into the transverter and convert it, multiply it to the VHF or maybe even UHF frequencies and out to our antenna. And it will also do the reverse. It will take the signal coming into the antenna from another amateur radio operator that's transmitting to us. We are listening to that operator, and it will take the signal into the antenna via the feed line or the coaxial cable into the transverter. The transverter will break down the signal into a lower frequency, a frequency in the range that the HF transceiver can receive, and send it to that transceiver. So it's converting both ways, and then we can listen to that signal. So when we transmit, the transverter ups the frequency or transfers it to the frequency range that we're interested in. And when we are receiving, it does the opposite. So that's what the transverter essentially does. It basically is a converter. And this is the definition that you would need for the exam. A transverter is a device that converts the RF or radio frequency input and output of a transceiver to another band. That allows you to use that same transceiver on other frequencies other than what is designed to through this accessory known as a transverter. All right, so let's come to another question that we will encounter about, that's the questions of RF power amplifiers, and one of the things as amateur radio operators, through our license, we're able to operate at pretty high power levels or outputs on the various frequencies in the spectrum, but we need to do so responsibly. In a conceptual way, we should not use any more power than is necessary to make our contact. That is one of the rules, in amateur radio operation. But sometimes we do need to drive a lot more power to make that contact. So sometimes our radio has a certain output. It might be 5 watts, it might be 1 watt, it might be 100 watts. And we may desire to have a higher output power. So if our radio is capable of 100 watts, legally on the HF band, many of the frequency ranges we allow to use 1.5 kilowatts. So if we need to drive to get from 100 watts output of our radio that it does natively, and we need to achieve 1,500 watts, the device that we need to use is called an RF or radio frequency power amplifier. All right, so let's get to a slide that shows that in use. Right. So let us say as a newly minted amateur radio operator, we just got our license. So we quickly purchase a handy talkie or walkie-talkie or handheld device, portable radio, sometimes we may call it. It's a handheld transceiver, and that's the device on your screen. And this device, it's pretty small. It's capable of perhaps 5 watts output through the antenna. And I'm using that, but I may have a base station antenna or I may have a mobile antenna, and I want to output more power on my handheld, and the handheld just simply cannot do that on its own. It's only capable of 5 watts of output power of RF power through the antenna. Why? It's because it's very small, it's very compact. The battery there can only deliver that much power to it. But sometimes I may want to increase my power because as a licensed ham, I can do much more than 5 watts output. So I may want to do 100 watts output so that I can make a contact. My signal can go even further. What do I use if I want to bump up or increase my output power from my transceiver? Now, we're just giving one situation here where we have a handheld device, but it could also have been a mobile radio. It could have been a base station radio that's doing smaller output power, but we want to increase the power. And what we employ is a device known as an amplifier, or specifically a radio frequency power amplifier. We put it in circuit, meaning that we will connect our radio. Maybe we'll replace this antenna, this rubber duck antenna, with a connector and use a feed line, maybe a jumper coaxial cable to this power amplifier, and then we will have another piece of feed line that goes to our antenna. This antenna may be on the top of our car, it may be on the top of our building or house, and we have this device here known as an amplifier. It will take the input signal as the output from this radio. So the radio is transmitting. It will go in at about, let's say, 5 watts or so, 4 watts, whatever the output power of this handheld is, and it will increase. It will amplify because this amplifier also has input power as well, electrical power, and it outputs a higher output on the radio frequency that we are transmitting. So it amplifies that signal. 5 watts in, and this particular transmitter or amplifier could do, let's say, 100 watts out. So we are able to use a small device like this that is only capable of outputting 5 watts, but we are able to do a much higher power using this RF power amplifier. So 5 watts in, and it can probably drive 100 watts output. So that's the purpose of the amplifier. And our license allows us to run higher output power. And these are the devices. If our native device cannot run that sort of power, maybe a base radio or mobile radio could do 100 watts. But if I'm using a smaller device and I want to output a higher power, the device that we employ is called an RF power amplifier. And we have a couple of exam questions that you will encounter. And the first one is, it says that an RF power amplifier is a device that increases the transmitted output power from a transceiver. And that's just what we talked about here. This is our transceiver. The output power is 5 watts and it increases it, let's say, to 100 watts or maybe 50 watts or whatever the amplifier output power is given the input power, right? So this is an exam question. It's essentially a definition of what an RF power amplifier is. So there's another feature on the RF power amplifier that we need to know about for the exam, and that is called a mode switch. So this mode switch allows us to operate other than, let's say, the standard modes where the signal coming in is a constant signal. You have modes such as single sideband, and if you're transmitting single sideband, that mode may not have a constant signal coming into the amplifier. And what may happen is, because it's not a constant signal coming in, it's a sort of choppy sort of signal, it may cause the amplifier to switch on, switch off quickly, click, 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 click. And you don't want your amplifier necessarily to be doing that. So for that mode, there is a switch that is a kind of sustained switch. It says, you know what, the signal that is going to come into me is going to be a sort of choppy signal. So I'm not going to release the amplification just because I see the signal drop off for a millisecond or so. I know it's a choppy signal, so I'm going to sustain. So those of us who probably, maybe use pianos, you have that sustain pedal on the piano. It keeps it, for a little bit longer. So that mode switch, when you depress it, it does not drop off the amplifier immediately just because the signal has dropped off a little bit because of the modulation scheme that is being used. And single sideband, for example, is one of those types of signals. You don't want the amplifier to be, click, clacking, click, 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 that way, because it may actually cause the output to not be regenerated properly. So that mode switch caters for those intermittent type modes that you may be transmitting into the amplifier. So you'll have a nice smooth output, notwithstanding the erratic nature of the input signal. And that's an exam question. The function of it's called the SSB/CWFM switch on a VHF power amplifier is to set the amplifier for proper operation on the selected mode. So that just simply means that if I'm going to use SSB, which is single sideband that you would have learned out before, or maybe even CW, you tell the amplifier that's the mode that's going to come in to prepare for it, so that it will treat it a little bit better than had it been a continuous signal mode. All right. So let's now talk about two parameters or two specifications about your transceiver. So we talked about what a transceiver is. Remember, we said it's a transmitter and a receiver word conjunction. So inside of our transceiver, we have a receiver and we also have a transmitter. But there are some specifications related to the receiver stage of our transceiver. And those two terms that we need to be familiar with, because they are exam related questions, but we'll go a little deeper in terms of what you will get in the exam, just for us to understand. We'll always like to do something extra in this course. So we have a couple slides, this slide and another slide, that goes a little deeper into those two specifications. It's sensitivity and selectivity. So the first parameter or the first specification on our receiver is sensitivity. Now, you probably already guessed or probably natively know what sensitivity means. It's in the nature of the word, sensitivity. How sensitive is it? Can it receive a weak signal? Or is it not as sensitive, so therefore it does not receive a weak signal? Right? So that's what sensitivity means, the ability to receive a weak signal. And that is one of the things that defines a good quality transceiver, or a good quality transceiver with a receive section that is very sensitive. You want your receiver to be as sensitive as it can get, because sometimes as a ham radio operator, especially in MCOMs or emergency communications, we might be listening out for that very weak signal. And therefore, if our receiver is not as sensitive as it can or should be, then we might be missing out. We might not be hearing that signal. Maybe it's in the noise floor and we're hearing a transmission, but we can't quite make it out because our receiver is not as sensitive as it should really be. And sometimes, quite often, that is one of the parameters or one of the specifications. You will look online and see receivers or transceivers, different price ranges, and you might say, well, wait a minute, and these two radios, What's the difference? Sensitivity is one of those parameters, depending on the number of stages that it has in the receiver section, a better quality, the ability to be more sensitive. So that's one of the specifications of a receiver that's very important, sensitivity. The other one that we come to is called selectivity. So what is that? Well, if you think about it, selectivity, selection, you want to be able to select, but select what? Well, I need to be able to select the correct signal. I don't want the signal to the left of me or to the right of me. I want the signal that is spot on. So if my receiver is not very selective, while I'm trying to receive a particular signal, I might also be bleeding in some of the signals to the left or to the right, or lower than or higher than the frequency I'm trying to listen to. I'm trying to listen to a particular frequency. Maybe you might have experienced that on the FM radio broadcast band. Maybe you're trying to listen to a weak FM station and you're hearing a station that is a little bit to the left or a little lower in frequency or a little higher. And you say, but wait a minute, that selectivity is not as good because I'm trying to listen to my weak FM station, but somehow or the other, due to something called capture, I'm hearing, it's maybe bleeding over, maybe those transmitters are not properly tuned, or maybe it's very close by, or they're running very high power. And somehow or the other, my receiver, because it's not as selective as it should be, I'm hearing the signals lower or higher in frequency than I want. And that also is another specification that determines the price of a transceiver. So as radio operators, you're starting to become very discerning. When you go into a store and you look at a radio, you look online, you might say, I need to pay attention to sensitivity and selectivity of my receiver. Maybe I want to see what the values are. And the next slide up, we'll show some values, we'll show some graphs, we'll show some information so that you will be a little more discerning as an amateur radio operator in choosing your radio equipment. You will know that all radios are not created equally. Sensitivity and selectivity are two of those parameters. Let's change slides. So we are still talking about transceiver specifications, sensitivity and selectivity, both of which are receiver specifications, right? So sensitivity, we have a couple of bullet points here. So none of these things are directly on the exam as such, right? We have a lot of extra information here for you to see what sensitivity is, what selectivity is, and we encourage you to read it on your own. But we have just excerpted a couple screenshots here for you to see what it might look like in a specification document for a transceiver. So if you're looking to buy a radio, you might want to go into that technical section. As a ham, you might say, whoa, what's all of that mumbo jumbo inside of there? But now, because you're exposed to some of these terms and what it probably means, you might be able to look at it and say, this receiver is more sensitive than the other, or this receiver is more selective than the other. And these are the parameters you're looking with. So in the middle of your screen here, sensitivity. These are the settings, or these are the values. So it shows you for this frequency range or the various frequency ranges what this sensitivity is. So 0.16 microvolts. And probably for the 50 megahertz band, this is 0.13 microvolts. So you can compare that to another transceiver, the receiver section. What is its sensitivity? And if it is better, well, you will know that that is a more sensitive radio, or that receiver is more sensitive. And look at selectivity here. This is what you will see in the technical specification section of that radio. You have selectivity for the SSB mode, right? It tells you bandwidth is 2.4 kilohertz, but look at the selectivity, more than 2.5 kilohertz, minus 6 dB. So these are some of the specifications that you may want to look at when you are checking and looking to purchase a radio. And we have some little graphs here that shows sensitivity against frequency. What that means is, depending on the frequency, a radio may be a little more sensitive or less sensitive at a particular frequency. In other words, it's not linear. The sensitivity is not necessarily the same across the spectrum of the radio's receiver. Sensitive on some frequencies, less sensitive on other frequencies. And then selectivity. You may want to have a signal where you are able to reject things that are lower or higher in frequency. So this is just a graph that shows the concept of selectivity. So a lot of extra information here for you, but hopefully you'll find this interesting and you can come back at it again and again and take a look at it, and the meaning will develop. But let's get to the exam questions that you will face. Right, so we are talking about sensitivity and selectivity. And these are specifically receiver specifications, okay? So we have the definitions that we need to learn. So we talked a bit about it already, but these are the definitions and you will get these in your exams. Sensitivity is the term used to describe the ability of a receiver to detect the presence of a signal. In other words, how sensitive is it that it can actually detect the signal? That's sensitivity. Selectivity, on the other hand, is the term used to describe the ability of a receiver to discriminate between multiple signals. So you want a specific signal. You don't want some signal that is to the left or to the right or lower in frequency or higher in frequency. You want to be able to discriminate and aim at a particular frequency and hear that frequency alone. You do not want interference from a frequency higher or lower. So this is the definition for selectivity. And these are the two definitions that you need to learn and know for your exam. All right. So let's do one more slide before we take our break. So preamplifiers. So we dealt with what an amplifier is, but we now want to talk about what a preamp or preamplifier is. So you saw this graphic before. We had our trusty handheld radio, our transceiver, and we showed that we replaced the stock antenna, this rubber duck antenna. We put a connector on and then we somehow connected it to this amplifier and to the antenna. And we said that the amplifier will take the signal input, amplify it, strengthen it, make it larger, more powerful, and send it out to the antenna so we get a longer distance. So we talked about that as the amplifier. But we're now talking about preamp or preamplifier. What is that? Well, the same device or maybe another device can function in the opposite direction, meaning that when it is in receive mode, this radio here is in receive mode, the antenna is receiving the signals from other amateur radio operators who are transmitting. It comes into the antenna and goes into the radio and we listen. But sometimes we want to amplify that signal that is coming in. We want to pull that signal in a little better. You know, we want to raise the signal level so that the radio can hear it. We can hear that person a little bit better. And that preamp or preamplifier stage or section is what will pull that signal in, amplify it in the other direction into the radio. So whereas the amplifier will send the signal out and amplify it and make it larger to go out to be transmitted, the preamp is really to receive the signal and strengthen the signal coming in. Right? So for your exam, an RF preamplifier is installed between the antenna and receiver. That's all you need to know for the exam, but we've just indicated how it functions, and that's where it's installed between the antenna, this antenna here, and our receiver. And notice we use an amplifier with a preamp button. So we push the button to turn the preamp on. It could also be a standalone preamplifier, but this is an integrated amplifier and preamplifier. There are so many options in amateur radio. So now is a good time to take a 2-minute break. So folks, let's probably get up, take a little stretch, maybe have some water, take a bathroom break, and we will come back in about 2 minutes and go through the rest of our theory, and then, of course, our trusty question pool review. 2-minute break. All right. Yeah. Good evening to you, the Adish. Yeah. Lundi. Okay. Hmm. That's a good question. Will we ever have to choose between sensitivity and selectivity when searching for a purchase? Well, like so many things, when we're procuring, let's say we decide to purchase a car, purchase a house, purchase anything that requires a significant investment, it really comes down to what we would like to invest. And yes, sometimes you may decide which one of those specifications are more important to you, depending on your circumstance, depending on the band that you're operating with and your usage. But quite often they tend to be matched. A radio that tends to have a higher sensitivity also tends to have better selectivity. There are options that radios can have, such as filters that improve those things as well as how many stages in the receiver. You will hear about double conversion and triple conversion and all sorts of things. And you will also see some of them are analog and some of them are digital or digital signal processing or software defined receivers, SDR, with an I and a Q signal and processing and post-processing and DSP. So yes, I would say you always have to choose depending on the investment that you want to make. And yes, sometimes you will say, you know what, this is more important, one specification than the other. Let me focus in on this and see how best the other setting could be as best as possible. But so the answer is yes, you sometimes have to choose which one is more important to you. But again, quite often they are matched. High end is high end at the end of the day. So once you have some specifications that are on the higher end, the others tend to kind of match with it. So very good question there, Lundy. And Colville. So in terms of purchasing radio, what brand would you recommend to get maximum sensitivity and selectivity? All right, so I will avoid unduly recommending any brands. I mean, all of the brands will have the higher end and the lower end, right? So there are what we call the Chinese branded radios, and they're notorious for not having very good selectivity and sensitivity, right? So we're just calling those Chinese branded radio. They're quite inexpensive. They're pretty good generally, but you have to take a grain of salt with that. But you have very good brands such as Kenwood, Yaesu, ICOM, and there are even commercial equipment that hams can repurpose as well. ICOM for sure, Motorola, and so on. So I don't know that there's any necessarily one brand that has maximum. You'll have to compare the models, and even within the brands, they will have different models as well. So that's the best I can say for now, Colville. Excellent question indeed. So let's see if we can return to our theory where we left off and continue. So, all right. So I think this is where we reach. Excellent question, folks. Very, very good. Okay. So let's continue. So there are a couple of circuits that we need to be aware of, and we will provide a lot more information than you necessarily need to know for the exams, right? But again, we are doing light touch theory with exam focus. That's the nature of our tuition, right? So we want to go a little bit into these terms that hopefully we can follow along and not just, learn by rote, but learn a bit by understanding. So we have been talking about circuits in previous sessions, and there are a couple of circuits that we need to be aware of. So if we're using a radio transceiver, and we said that our transceiver has a receiver in it, and it has a receiver stage. That receiver stage is really a receiver circuit. And in the receiver circuit, there are two key terms that we need to be familiar with in a receiver circuit, and that is mixer and oscillator. So we need to be familiar with the function of the mixer and the oscillator. So on your screen, we just have a little bit of a almost block diagram to show the interconnection between the stages. Don't worry too much about it. You don't need to learn it on someone per se, but it's just a little reference. This is actually what it will look like in a block diagram. And mixer and oscillator. So what the mixer does, it actually converts one frequency into another frequency by processing it. So in a receiver, we'll have our antenna, we'll have a little amplifier that sends it to the mixer stage. And that frequency, which is radio frequency, we apply another frequency that is generated by a circuit called an oscillator or a local oscillator. The mixer now takes those two frequencies, the one that we're trying to listen to, so it's received via our antenna, and that frequency is mixed with another locally generated frequency called the local oscillator frequency. And when that mixer mixes those two frequencies, what it produces is a sum and a difference frequency. So it adds the two frequencies and produces an output. And it also subtracts the two frequencies and produces an output, and it discards one of them through a filter. So the mixer takes two frequencies in and generates another frequency out. And we're actually interested in the lower frequency that it generates. And that is actually called the intermediate frequency stage, right? Or the IF. The oscillator is a little circuit. It's a highly stable circuit that generates a precise frequency. And that frequency that is generated is selected specifically so that when it mixes with the incoming frequency that we want to listen to, it produces a particular output frequency, or what is called the IF stage. So mixer takes two frequencies in and produces an output frequency or frequencies. The oscillator is locally generated, a little circuit that sends that frequency to the mixer. So that's the relationship between the oscillator and the mixer. All right, so we have a little expanded view here that basically shows what we just talked about. Again, this is our receiver stage in our transceiver, and we are trying to listen to a frequency. We are on the air and we have tuned our radio or tuned our transceiver, tuned our receiver to a particular frequency. It comes in, it's amplified, goes to the mixer, and our oscillator generates that frequency that when it goes into the mixer, it produces a sum and different frequency. And this is called the IF, or intermediate frequency. Just to let you know, the oscillator produces a frequency that when mixed with the input frequency is such that the IF is always the same. And why that is important is because it allows lower cost electronics to be able to amplify and filter and select and all that sort of thing. So there's a purpose that we are trying to get to a particular frequency in the output. So we tune our receiver in such a way that we listen to a particular frequency, but it's the oscillator that generates a matching frequency that delivers a particular output, because the mixer is taking the two and summing and differencing, and we filter out one and we take the other one, and it goes to the other stages where it will detect and listen, and all of a sudden now you are listening to a transmission. But these are the early stages of a receiver. So what we need to know for the exam, we'll come up with the 2 bullet points shortly, but we need to know what a mixer is and what an oscillator is. And we're just showing the relationship here. Feel free to read the slides. It has a little bit more detail that hopefully will help us understand. And, hopefully we're not too confused by all of this mumbo jumbo. It's a receiver circuit, and these are the stages and these are the components. Let's get to the exam questions. So for the exam, we need to know the definition of a mixer. And it's what we just discussed. A mixer is used to convert a signal from one frequency to another. It's as simple as that. The frequency is converting, though, is we are trying to receive a frequency and we are trying to achieve a particular intermediate frequency output. And therefore, the oscillator, which we'll come to the definition in a little bit, is mixed with that frequency we are trying to receive. That's our objective, to listen to a radio transmission through our antenna and listen to what it is saying. And the mixer is that important component in what you call a superhet or super heterodyne type receiver. It mixes with a local oscillator to produce the IF. So a mixer is used to convert a signal from one frequency to another. An oscillator is the name of a circuit that generates a signal at a specific frequency. So we said the oscillator, or the local oscillator, is a circuit and it's generating a frequency for us. And that frequency that it generates, it's important because it has to be mixed with the incoming frequency that we're trying to listen to produce a particular frequency on the output. So a very generic definition, but it's one that we need to learn for the exam. An oscillator is the name of a circuit that generates a signal at a specific frequency. So it's oscillating and generating a frequency that goes into the mixer. All right. So we need to know about modulation, but modulation should not be a stranger to us. We have discussed it many times. We said, there are different types of modulations, and we showed where we will put our voice onto a carrier and we modulate that carrier and we end up with a radio frequency output. But we are reintroducing it here again because there's an exam related question. So let's talk about modulation again. So we said that our radio will generate this frequency called the carrier frequency. So whatever it is, maybe it's 7.159 megahertz. That's the carrier frequency. And then I speak, or maybe I'm using a digital mode and our computer generates some tones. But I speak, and that's my voice. And I superimpose my voice, which is the modulating wave, onto the carrier wave, and then we end up with this. So we are modulating the carrier, and we end up with this frequency, and it goes to our antenna, and it goes out into the air, and someone else receives it. And of course, there are different types of modulation. We talk about amplitude modulation, where we change the amplitude or the height of the wave. And then we can do frequency modulation, where we change the frequency when we use our voice and put it onto the carrier. So different types of modulation, digital, we have phase, we talked about all sorts of modulation. So again, just a bit of a diagram to show what we mean by modulation. We may speak into a microphone, so we have our audio frequency, then it goes into the radio, and then we end up with radio frequency that goes out to our antenna. So we are modulating that radio wave. And the exam question talks about modulation and describes it as combining speech with an RF carrier signal, which is exactly what we've been talking about all along, what modulation is. But this is an exam question that you need to know. This should pose no difficulty for all of us. So let's go straight on now to talk about radio frequency interference. So a lot about our training as amateur radio operators is how to avoid causing harmful interference and also to minimize it, and also how to troubleshoot solving radio frequency interference problems. So we are generating radio frequencies. So invariably, like so many things in life, when we do something, we have the potential to cause issues. And as ham radio operators, radio frequency is what we're dealing with, and therefore we can have radio frequency interference. And there can be various sources of radio frequency interference. We can cause radio frequency interference in other services, and other services can cause interference to us. So we can generate and we can also receive. So we need to be aware of it because we are doing radio frequency transmissions and reception. There are so many sources of radio frequency interference, and we have a couple of them on your slide here. These are not in your exam, but again, we'd like to learn and understand what it is about. So power lines, electrical appliances, devices, lightning strikes, all of those things can be sources of interference that affect us as amateur radio operators. It can attenuate signals. It can cause us to not listen or hear or receive our incoming signals. So these are some diagrams that we have here to show the radio frequency spectrum and some things that can cause us interference, or maybe even devices that we can cause interference to. So one concept that we need to know for the exam is called fundamental overload. So what is fundamental overload? So if we were to look on the right-hand side here, this is our diagram of a spectrum, a radio frequency spectrum. And what is encircled in blue here is the frequency we are trying to listen to. Now, this could easily be an amateur radio frequency. We can think of it maybe as a broadcast FM radio broadcast frequency, maybe 95.1 FM. So let's talk about it in that context. So I'm trying to listen to 95.1 FM, but I have some adjacent frequencies. Maybe I have 98.9, maybe I have 94.1 below, and they are very strong signals. Notice that below are very strong. Look how strong the signal is. Look how strong the signal is. And the signal I'm trying to listen to is not as strong, or it's relatively weak. So depending on the situation, depending on the quality of my receiver in particular, I may suffer from a phenomenon known as fundamental overload. These adjacent frequencies may cause me to not listen to this frequency as well as I should have. Maybe because of the quality of my receiver, it may cause, I cannot reject these two. I'm not selective enough. Right. So again, this is where concepts like selectivity comes in. I cannot select this frequency alone. My receiver is too wide. It's not as selective as it should. So these frequencies, due to maybe FM capture, is causing this signal to be attenuated, or these are overshadowing this frequency I'm trying to listen to. So in amateur radio, that happens. I'm trying to listen to an operator transmit on this frequency, but there are other radio operators or maybe interference signals that are just nearby, and I suffer from fundamental overload. Right, so another concept is the concept of harmonics. What exactly is a harmonic? Well, as an amateur radio operator, we are generating radio frequency. We need to be aware that any source of radio frequency, whether it's our transmitter or transceiver or even some other natural source, when there's a frequency generated, quite often there are harmonics also generated. What do we mean by that? So if I am generating a frequency, let's say 7.159 megahertz, when my transmitter generates that frequency, it is also generating multiples of that frequency that are called harmonics. So it generates the second harmonic, the third harmonic, the fourth harmonic, which is a multiplier of the original frequency. It generates that. So radio transceivers should have filter stages that filters out. So if I'm generating this frequency, this one in red here, right, this sine wave here, I'm generating this frequency. My circuit that is generating this frequency is also going to be generating a frequency at twice the frequency. It's going to do one at 3 times the frequency. It's going to do one at 4 times and 5 times and so on. Naturally, it's going to do that. I need to filter these out. So those harmonics can be a problem because those frequencies may also be used by another service. So imagine I'm generating this frequency, but I'm also interfering with another service on the frequency that is twice the frequency I'm using. That's not a good thing. So our transmitter frequencies are supposed to have filters that filter out these extraneous frequencies. Again, it's natural to be generated. So we need to be aware of them and we need to minimize them. Otherwise, we can cause harmful interference to another service. Similarly, we have another concept called spurious emissions. Again, all of these are radio frequency interference patterns. And what exactly is spurious emission? So imagine we have our transmitter and we encase it in a metal box. So it shields any sort of stray radio frequency that's generated inside. We need to keep it inside. Our coaxial cable that goes out should also be shielded to avoid sending out extraneous frequencies. But if we are not properly shielded, especially internally or between devices, those signals may leak out. So we tend to call that leakage of unintended frequencies or unwanted signals spurious emissions. Not desirable, but it can exist. And we can do our best to shield it or to avoid these spurious emissions from occurring. And it can occur from within a chassis or a box or container or the whatever our transceiver is contained within, the casing. It can occur there if it's not properly shielded. Maybe we unscrewed the top cover and we left it off, and all of a sudden now we are emanating spurious emissions. Or maybe our cable, the outside shield is broken between devices, and all of a sudden it's acting as an antenna and sending out the signals through that shield. So spurious emissions, not desirable, and it's considered radio frequency interference. Okay, so for the exam, so we went into a bit of detail as to what those 3 concepts are, but all you really need to know for the exam is that these concepts that we just introduced are examples of radio frequency interference or are the causes of radio frequency interference. So this is the exam question that you're going to encounter. The following can cause radio frequency interference. We dealt with what fundamental overload was, we dealt with what harmonics are, and we also just quickly touched on what spurious emissions are. So these, all three of them, can cause radio frequency interference. Now, when radio frequency interference is caused, meaning that we are causing interference, or sometimes interference is caused to us, we need to know what can we do, what steps can we take to solve these interference problems. And we need to be aware of the causes. So, for instance, if it is our neighbor, we are an amateur radio operator, we have our station, we have our antenna on the outside, our lovely HF antenna, and we have our transceiver on the inside with a very strong 1.5 kilowatt amplifier, and we are transmitting. And then our neighbor says, hey, your transmission is interfering with my reception. Maybe, okay, Trinidad and Tobago, we have TV6 that's still broadcasting on the air. And on your screen, if you look at this, this is a television broadcast screen. And if you see wavy lines like this, when you transmit, well, that means we are causing harmful interference or interfering with our neighbor's television. So this is an example of radio frequency interference, right? So how do we solve it? Well, one of the steps that we can take is if our neighbor says that we're interfering with their transmission, maybe what we can do is tune our television also to the same channel and see if when we transmit, we cause interference to ourselves, right? Because if we are interfering with our neighbor's television, there's a good chance we might be interfering with ourselves. But if we do not, well, that also tells us something. So that's an exam question. The action that should be taken if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception is to make sure that your station is functioning properly and that it does not cause interference to your own radio or television when it is tuned to the same channel. So that's what we just said here. If they complain about it, check your own TV and see if you are also causing this type of interference to your TV, which is actually even closer or should be closer than your neighbors. So one other thing that you can do is if you hear, well, you're causing interference to your neighbor or even to yourself, one of the things that you can do is if you look on your right-hand side here, you may see these connectors. They may be familiar to you. Maybe you have a cable television feed, or maybe this is the type of connector coming from your antenna for the direct-to-air television service. And these are connectors. One of the things you want to make sure is that these connectors are properly installed. They go straight on in and they are tight, nice and tight, and they're not loose or they're not cross-threaded or somehow or the other, and the connector is properly made up and so on. Because if this is not properly inserted, it can receive or cause interference to be received by the device. So that is actually one of the troubleshooting steps that you take as an amateur radio operator to be responsible for your own station and for your own, let's say, household, family members, and so on, but also your neighbors. That's advice that you can give them if they're getting or receiving interference. Make sure these are nice and properly installed and nice and tight. So that's the second bullet point, exam question. The first step to resolve non-fiber optic cable TV interference caused by your amateur radio station is to be sure all TV feed line coaxial connectors are installed properly. So let's dissect this a little bit. First step, to resolve non-fiber optic cable TV interference. What do they mean by that? So we have a lot of fiber optic services coming to our homes, but we may also have coaxial type services, these sorts of cables, right? So they're talking about the coaxial type cable that's coming in. So in Trinidad and Tobago, that will be, for example, Flow. Digicel is an example of a fiber optic television service. Flow is an example of coaxial type service. So that's what they simply mean by non-fiber optic TV interference, right? Caused by amateur radio station. Make sure that all feed line coaxial connectors, that's these here, these are the feed line coaxial connectors, are installed properly, meaning that they're not cross-threaded, they're not at an angle, they go straight on in, and they're nice and tight. Exam question. Okay, so there are other steps that we can use to resolve radio frequency interference. Now, in this case here, we are talking about interference caused to our amateur radio station. So we have our nice big HF antenna on the outside of our house, and it's feeding our radio, and we are getting interference, maybe from a broadcast radio station, right? Or a broadcast TV station or something like that that's broadcasting. Maybe we are close to one of those transmitters. And maybe it is that our station or receiver is not able to reject those stations, right? Also, we talked about fundamental overload that can occur on our stations, right? So we may want to use a device to filter out that interference that we may cause on our broadcast AM, FM radios, right? So those are the 2 bullet points that you have on your screen here. So let's go through them very quickly. A cause for a broadcast AM or FM radio to receive an amateur radio station radio transmission unintentionally is that the receiver is unable to reject strong signals outside of the AM or FM band, right? So that's the first bullet point. It's an exam question. Let's deal with the other one. Fundamental overload. So we dealt with what that was. We dealt with the concept of a non-amateur radio or TV receiver. So what we mean by non-amateur radio or TV receiver, it's, for example, this broadcast radio that we have here, by an amateur signal, meaning that our amateur radio station is causing interference on this broadcast receiver, can be reduced or eliminated by blocking the amateur signal with a filter at the antenna input of the affected receiver. So let's break that down a little bit. What they're saying is that we are receiving interference on this broadcast radio from an amateur station, right? That's what's happening. So we are saying that we can solve that problem by installing what is called an input filter. So this here is a filter that we put onto the antenna of this radio, and hopefully putting the filter in will filter out the interfering signals. So that's the exam question. Fundamental overload of a non-amateur radio or TV receiver by an amateur signal can be reduced or eliminated by blocking the amateur signal with a filter, that's the filter here, at the antenna input of the affected receiver. So hopefully all of that is straightforward. Let's continue. Other resolution steps. So in this case here, our amateur radio station is getting interference from a FM broadcast station. So this is an example of what a broadcast station transmitter tower might look like if you've ever seen one. Sometimes they tend to be on hills and or very tall buildings. These are what's used by our FM broadcast stations, right? Commercial broadcast stations. And they can cause interference to our amateur radio station. So this is our VHF radio, and we may be getting interference from that FM broadcast station. So the FM broadcast station is transmitting maybe 10 kilowatts of power, 50 kilowatts of power, 100,000 kilowatts of power, or even more. And that is further amplified because of the gain of the antenna. So effectively, a lot of power. And maybe we are close by enough to this broadcast station. So this is our antenna, our receiving antenna, and it is close and causing us a lot of interference. But we can solve that by putting in a filter that's called a band reject filter. So this is an example of what a band reject filter might look like. There are different form factors to it, but it's just the one that we have put up here on your screen to make it real. So we connect it between the antenna and our transceiver so that the interfering signal that is coming in could be filtered out, and therefore we only receive the signal that we are interested in. So that's called a band reject filter. And that's the exam question. It says that installing a band reject filter, this device here, can reduce overload of our VHF transceiver. This is our amateur VHF transceiver by a nearby commercial FM station. And this is the nearby commercial FM station that is causing us the stress, right? So we can use this to eliminate that form of interference. Okay, let's continue. So We may also cause or receive interference from our neighbors, right? So if it is that our neighbor is causing us interference, so for example, they may have a device that is transmitting. So what we have here is a little mouse that's transmitting, low power RF. It's a part 15 device, so it's not supposed to cause harmful interference to other authorized services. That's what we put that up here for. That's the FCC rules, and any jurisdiction around the world will have similar rules. These generic devices are not supposed to cause harmful interference. So I've just put up one, a mouse. So, but our neighbor is causing us stress. We are amateur radio operators and they're affecting our reception. What should we do? So the first thing we should do is work with our neighbor to identify what device is causing that harmful interference. If we are able to identify it, maybe as hams, we are able to discern or determine the source of that interference, and it's coming from our neighbor, we may be able to determine what device it is. We should politely tell our neighbor about it as best as we can. And of course, if they are challenging, we should point out that the FCC rules permit their device from interfering with our service, right? Very politely, right? And of course, we need to make sure that our station is also not at fault, that we have installed it properly and we are operating properly. So we should also make sure that we are not prone to receiving that interference, right? So for example, having our stations properly grounded, proper coaxial cable that's not frayed, and, poor connections and corrosion and so on. We should make sure that our station is properly installed. All of the theory that we have done over the couple of weeks, good practices and all of that, right? We need to make sure that our station is in good order. So for the exam, if something in a neighbor's home is causing harmful interference to your amateur station, you should, 1, work with your neighbor to identify the offending device. That's the first thing. Then politely inform your neighbor that FCC rules prohibit the use of devices that cause interference. And lastly, well, probably not lastly, but also make sure that your station meets the standards of good amateur practice. We all have a responsibility. All right, so we have a couple more slides still to go. Right. All right, so common problems with amateur stations. Well, here's another one. For example, you may, in operating your radio transceiver, find that you're hearing someone sounding distorted, or they may tell you that you are sounding distorted. So I'm an amateur radio operator. I'm using my handheld device. I am talking on a repeater, and we talked about what a repeater is. A repeater receives our signal on one frequency and retransmits or rebroadcasts it to a wider area so other people can hear it that's further than we would be able to reach directly. And maybe there's this hill here and I'm trying to talk to another amateur radio operator on the other side of the hill. But I'm doing so via the repeater. The repeater is allowing me to extend my transmission to a much wider area coverage. But then the amateur radio operator says, I'm sounding weak, or I'm sounding distorted. They cannot understand what I'm saying. They know I'm talking. They could probably even make out my voice. What could be one of the things that's causing that? I'm on the repeater and I'm transmitting. So the first thing is, of course, I'm in a bad location. I don't have good access to the repeater. So maybe I'm in a little cove, or I'm inside of a building, or maybe I'm inside of a car or somewhere, and I don't have good access, line of sight to the repeater. So I may need to relocate myself. And that is one thing that could cause me to sound distorted. But another one is that my battery could be low. And because of that, not enough power is being transmitted to the repeater. And therefore, I'm sounding weak, I'm sounding distorted. And there's another reason as well. As an amateur radio operator, you have a frequency display. And right now, we are showing 146.820 megahertz. That's a frequency that we are transmitting on. Maybe I'm supposed to be on 146.825, but I'm inadvertently on 820. So I'm actually slightly off frequency. And that can happen because I'm on VFO mode. I'm not in channelized mode. I didn't save the frequency. I'm just tuning in and I'm tuning my dial, and I inadvertently did not select the correct frequency. So I'm slightly off frequency. Now our transmission will get to the repeater, and the repeater will happily rebroadcast it. But because I'm slightly off frequency, I will sound distorted or garbled, right? So those are actually points in an exam question. It says if you receive a report that your audio signal through an FM repeater is distorted or unintelligible, the problem might be 1, your transmitter is slightly off frequency, 2, your batteries are running low, or 3, you are in a bad location. So those are some of the common problems in amateur radio. And once you're aware of these things, once somebody tells you, hey, you're sounding weak, you're sounding distorted, these are a couple of the things that you will diagnose quickly and see if it is in fact so. You can check your battery, you might see 1 bar or almost no bars and say, yeah, my battery really is low. Check the frequency display, make sure you're actually transmitting on the frequency that you're supposed to, that the repeater is listening on. And maybe you need to relocate. You say, yeah, I'm really in a bad position. I am kind of behind a building, or I'm inside of a building, or inside of a car. I may need to step out or step away or relocate to improve my signal going to the repeater, so I will be heard loud and clear. Okay, so some other common issues that we may encounter in operating our amateur radio stations. So there's a mode of interference called RF feedback. So RF feedback means radio frequency feedback. So if we were to look on our right-hand side, we have a diagram here. This is our transceiver. This is the antenna coming in, and we have our audio circuit. So we are listening to, someone is transmitting, and we are listening, and then we may now transmit. And sometimes what happens is that there's feedback that is coming in that causes the audio to be distorted. So we are saying that one of the symptoms of that RF feedback is reports of garbled, distorted, or unintelligible voice transmissions. So that can happen. I may be talking to someone, I'm keying the push to talk, I'm transmitting, my signal is going out, but guess what? It's also coming back in, and it's affecting the audio circuit. So it's not only my voice that is modulating the signal that's going out, but that interfering incoming RF from my output, by the way, is also impinging on my audio circuitry. So my voice is also being garbled. So when it goes back outside, it is garbled, distorted, or what we say unintelligible. And that is called RF feedback. And that is one of the symptoms, and that's an exam question. A symptom of RF feedback in a transmitter or transceiver is reports of garbled, distorted, or unintelligible voice transmissions. RF feedback, and that's how it sounds, and that's what the report you will get from the other amateur radio operator that you're talking to. They will report that to you and say, hey, you're sounding distorted or garbled, and that's one potential. Another issue that you can possibly have. So on our left-hand side here, we are showing an FM transmission. Remember I said frequency modulation is where the frequency is shifted according to our voice pattern. So that's FM. So with that, there's a deviation. So if this is the frequency that we are transmitting on, when we shift the frequency in tune with our voice, we have a deviation in the frequency. And there's actually a maximum deviation that's called the peak deviation. But if we overmodulate, we transmit, we drive that audio too much, then we will deviate more than the specification allows. It's called over deviation, right? And if we over deviate, we can actually transmit out of band. That could happen as well, right? But what causes it is if we are driving our audio too hard, or if we are over modulating, we can cause over deviation. Maybe we are too close to the microphone and therefore our voice is loud, and maybe the circuitry in the radio does not sufficiently compensate for it, or maybe we have turned that feature off, and that over driving of our voice into the transmitter, we are speaking too loudly or too close, causes the FM signal to over deviate. It should not go beyond this area here. It goes all the way out here because we are maybe shouting into the microphone, or maybe we are speaking too closely to the microphone, and the deviation of the FM signal is more than the specification. So that's an exam question. If you're told your FM handheld or mobile transceiver is over deviating, that's what another amateur radio operator tells you. What you should do is talk a little farther away from the microphone, and that could help resolve it. Help resolve the issue of you are overdriving and causing over deviation. So we now come to a couple of test instruments, and we need to know the definition of some of these. So on your right hand side here, we have what a multimeter would look like. So this is a tool that we often use to take measurements. Remember, we dealt with voltage and current and resistance. If we want to measure those things, we use something called a multimeter. We use it to troubleshoot quite often circuit issues. And this is the multimeter, and these are the leads, these are the probes that we will connect to the circuit, and we'll have a display that reads out whether it's the voltage or whether it's the resistance on the display. And this is a digital type. Of course, they are analog types with needles instead of a digital readout. But we need to know for the exam that voltage and resistance are measurements made using a multimeter. This is our multimeter. We can measure voltage and we can measure resistance. So when we measure voltage, we use the voltmeter part of the instrument. So it can be a multimeter or it can be a standalone meter called a voltmeter. And when we put it across the circuit to be measured, we are measuring the electrical potential. And that's an exam question. A voltmeter is the instrument you would use to measure electrical potential. Remember, we call it the electromotive force as well. And we have a little diagram here that reminds us about the water circuit analogy with respect to circuits. This is the electric circuit with electrons, and this is our water circuit using water. So we are just reintroducing or reminding ourselves that we have been using water circuit analogy to describe electric circuits. So this is just a reference here for us as well. But we also need to know when we are using a voltmeter, how do we connect it, whether it is in series or parallel. So we need to know the voltmeter is connected across the component that we are trying to measure the voltage of. It is also considered to be in parallel, and that's an exam question. A voltmeter is connected in parallel to a component to measure applied voltage. So this is the resistor here. We are trying to measure the voltage across the resistor. We use the probe and connect it across, and that is parallel. So when we are measuring using a voltmeter, we have to be very careful. So we want to measure voltage, but remember, in the case of a multimeter here like this, we have to make sure we select voltage. But if we inadvertently select resistance, let's say we inadvertently put this selector on resistance instead of voltage, and we put it into the circuit, we can damage this meter. So that's an exam question. Attempting to measure voltage when using the resistance setting can damage a multimeter. It would be a very expensive mistake. So we need to be trained, we need to be aware of it. And from now on going forward, we shall not make that mistake. Okay. All right. So there's also another precaution that we need to observe when we are taking measurements. Again, safety first. We need to be very safe. So we need to make sure that when we use instruments, that they are rated for the purpose. So if, for example, we are using this instrument, we are using the probe or the leads to measure a particular voltage, we need to make sure it's rated for the voltage that we're going to measure. It stands to reason, right? If we are going to measure up to 600 volts, we should use an instrument that's rated for 600 volts. We should use leads that are rated for 600 volts. Or whatever it is rated for must match what we are going to measure, and with a safety headroom as well. So that's the next exam question. A precaution that should be taken when measuring high voltages with a voltmeter is to ensure that the voltmeter, that's this, and the leads, here are our leads, are rated for the voltages to be measured. It should not be any lower. It can certainly be higher or much higher in terms of its rating, but never lower. All right. So if we are taking measurements of resistance, we use an ohm meter. And how do we measure using an ohm meter, right? So we need to know that we need to use an ohm meter and connect it in parallel to a component to measure its resistance. So if we look at it here, you have some resistors tied like this together, and you want to measure what the total resistance is. This is how you will connect it in the circuit to measure the resistance. So the key there is parallel. And we also need to be aware that if we are trying to measure resistance, we have to ensure for safety purposes that the circuit is not powered, right? So that's the bullet point number 2. It's an exam question as well. Folks, remember, anytime you see a bullet point with this yellow writing, it is most likely an exam question. So a precaution that should be taken when measuring in-circuit resistance, that's this, with an ohm meter, is to ensure that the circuit is not powered. So we have here 2 resistors. It's not actually in a circuit. It's by itself. So there's no DC power. There's no AC power. There's no power here at all. So that is safe. If it is inside of a circuit we're trying to measure, we have to make sure that everything is off and the capacitors are discharged, right? So safety first. Always remember that. And that's another point that is useful to know if you are measuring a circuit. And this is an exam question. A reading which indicates that an ohm meter is connected across a large discharge capacitor is increasing resistance with time. So if you put it in circuit and you see the resistance start to increase, that suggests that you have a capacitor in the circuit, because that's what will happen. This meter here, the ohm meter, will start to charge up the capacitor, and as the capacitor becomes charged, the resistance in the circuit tends to increase. So that is one telltale sign that you have a capacitor in a circuit that you are measuring the resistance of, and that's an exam question. Okay, couple more slides. Right, so an ammeter is used to measure electric current, right? So this is our ammeter here. We put it in the current mode, and that's an exam question. An ammeter is an instrument used to measure electric current. So it's an ammeter. And we are also showing here how it's connected. It's connected in, is it parallel? No, it's connected in series. And we have our trusty water circuit analogy here to show where we will connect the ammeter. So it has to be in series to measure the current that is flowing through it, right? So it's not in parallel like we have seen when we are measuring voltage. It is in series, and that is also the next exam question. When configured to measure current, a multimeter is connected to a component in series. So what they mean here, we have the multimeter. It can measure voltage, it can measure current, it can measure many other things, resistance. But we have to put it in the mode to measure current, right? So it's a multimeter, but it's functioning as an ammeter at that point because it's measuring current. And we have to put it in series, which is the last bullet point, exam question. All right, so last couple of slides, we need to know what solder is. So on your screen, we have a roll of solder, and we have a little blow up of what solder looks like, right? So we have the solder right here, and we have the actual metallic component, and then we have what is called the flux or resin core inside of there that makes soldering not only easier, but also makes the solder make a better connection, right? So this is what a blow up of a cross-sectional area of solder looks like. And of course, it's a circuit board here, and we're seeing how someone is soldering. They're using a soldering iron, and this is solder here, and they are connecting the component to the circuit board. Nice connections that are being made. So that is what solder is. And we have a couple of questions associated with solder. All right, so we need to know for the exam that we are, well, resin core solder is what we should use. We should not use acid core solder. So if you were to go back to the slide previously, you notice it says resin core. That's the type we should use in amateur radio for electronics, not acid core, right? So acid core solder is a type of solder that should not be used for radio and electronic applications, right? So say no to acid core. All right. So we need to know the difference between a good solder joint and a bad solder joint. So if you look at the right-hand side diagram here or the picture, you will see some dull looking joints. It's looking dullish. It's a ball of solder there that's just resting there. It may not be properly made. So these are called cold solder joints. On the right-hand side, notice how they are shinier. They seem to be a little more integrated. It's not too blobby like this one. It's certainly not dull. It's kind of shiny. So these are good solder joints. And you need to know that for the exam, that the characteristic appearance of a cold tin lead solder joint is a rough or lumpy surface, which is this across here. So these are bad solder joints. Cold tin lead solder joint, rough or lumpy or dull. And good solder joints are nice and shiny. So these are the two exam questions. And folks, this is our last slide in the slide deck. So let us go quickly now to, well, the usual slide that we have. This is one that we'll keep repeating in the slide deck just because it shows us the frequency ranges and what's VHF, UHF, and HF. So good trusty table to have when studying material so that we can see the frequency ranges, the wavelengths, and what band it is, and even whether we use lower sideband or upper sideband. So good trusty diagram to have. But let us go straight now into our question pool review, where we deal with the questions related to the theory that we have covered this evening. All right, let's go straight to it. What is a transceiver? A transceiver is a device that combines a receiver and a transmitter. Transceiver, transmitter, and receiver. Next question in the question pool. What device converts the RF input and output of a transceiver to another band? So we call that device a transverter. Next up, what device increases the transmitted output power from a transceiver? So we have one power in and a higher power out. That is called an RF power amplifier. Okay, next question. What is the function of the SSB/CW-FM switch on a VHF power amplifier? So remember we said that those modes are very choppy type modes. May cause the amplifier to clickety-click and result in a poor performance output for the particular mode. Well, that switch is to set the amplifier for proper operation in the selected mode. Next question. Which term describes the ability of a receiver to detect the presence of a signal? That is sensitivity. Next question, which term describes the ability of a receiver to discriminate between multiple signals? That term is selectivity. Okay. Where is an RF preamplifier installed? We showed a diagram that it is between the antenna and the receiver. Where else can it be? Okay. Next question, which of the following is used to convert a signal from one frequency to another? So that's the circuit. It's called a mixer. Right? And remember, we use that in a receiver. Okay, next one up. What is the name of a circuit that generates a signal at a specific frequency? So remember, we had that local oscillator there in the mixer circuit. So it's called an oscillator. Next one. Which of the following describes combining speech with an RF carrier signal? So when we have the carrier signal and we use our voice and we impose it on the carrier, that is called modulating or modulation. Okay. Next question in the question pool. Which of the following can cause radio frequency interference? So we went through those points. We defined a bit what they were, and all of the points here are correct. Fundamental overload. We also discussed harmonics and we discussed spurious emissions. All of those can cause RFI or radio frequency interference. So therefore, all these choices are correct. Right. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? So we said that make sure that your station is functioning properly and that it does not cause interference to your own radio or television when it is tuned to the same channel. So that's an action that you should take. Neighbor complains, check your own station and see if it's being interfered with also. All right. What should be the first step to resolve a non-fiber optic cable TV interference caused by your amateur radio transmission? So let's dissect this question. So they're asking us, what is the first step? But first step to do what? Resolve. Resolve what? Interference. But interference of what? Non-fiber optic cable TV. So not the digitals and so on, but maybe like the flow, or maybe just the regular broad direct to air television. Caused by what? Your amateur radio transmission. So what's the first step to resolve? The first step is to make sure that those TV feed line coaxial connectors are installed properly. Nice and straight, nice and tight. Next question in the question pool. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? What would cause that? Well, the receiver is unable to reject strong signals outside of the AM or FM band. Next question in the question pool. How can fundamental overload of a non-amateur radio or TV receiver by an amateur radio signal be reduced or eliminated? Well, what we can do is use a filter. So we can block the amateur signal. Sorry, I say again, block the amateur signal with a filter at the antenna input of the affected receiver. So essentially we install a filter. Next question, which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? So what we do in our amateur Radio Shack is we install a band reject filter. Okay, next question in the question pool. What should you do if something in a neighbor's home is causing harmful interference to your amateur station? Well, all of these points are correct. You work with your neighbor to identify the offending device. You politely inform your neighbor that the FCC rules prohibit the use of devices that cause interference. And you also make sure that your station meets the standards of good amateur practice. All of those are correct. Next question. What might be the problem if you receive a report that your audio signal through an FM repeater is distorted or unintelligible? So again, all of these answers are correct. The problem could be that your transmitter is slightly off frequency. Problem could also be that your batteries are running low. The problem could also be that you are in a bad location. All of these are correct. Next question. What is a symptom of RF feedback in a transmitter or transceiver? So one of those symptoms are the other amateur radio operator will give you reports of garbled, distorted, or unintelligible voice transmission. They'll say that you're sounding bad. Okay, next question. What can you do if you are told your FM handheld or mobile transceiver is over deviating? Right, so that is caused by driving your audio too hard and the FM transceiver is over deviating. What you can do is just pull away from the microphone just a bit, and that is talk farther away from the microphone, and that should help. Okay, next question in the question pool. Which of the following measurements are made using a multimeter? So you can get voltage and resistance measurements from a multimeter. Okay, let's go. Next question. Which instrument should you, I say again, which instrument would you use to measure electric potential, which is voltage? So the answer is a voltmeter. Right? So remember, electric potential or electromotive force is voltage. What do you use to measure that? Well, a voltmeter. It's voltage, right? Good. How is a voltmeter connected to a component to measure applied voltage? So what we use the leads and put it in parallel to measure the voltage across the device. Next question, which of the following can damage a multimeter? Well, if you attempt to measure voltage when using the resistance setting, that can pretty much fry your multimeter. So try to remember it. Try not to make that mistake. I could assure you, the first time you make that mistake, it will be the last that you make. You remember that forever, okay? You'll see, poof, a puff of smoke. All right, let's continue. Which of the following precautions should be taken when measuring high voltages with a voltmeter? So we need to ensure that the voltmeter and the leads are rated for use at the voltages to be measured. That's a precaution. Next question in the question pool. How is an ohm meter connected to a component to measure its resistance? So it's an ohm meter, it's measuring resistance, and therefore we need to put it across the device, so that is in parallel. See how important the concepts of series and parallel comes in understanding and troubleshooting and answering exam questions. Right, which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter? Well, the precaution is we have to make sure that the circuit is powered down. So ensure that the circuit is not powered. Next up, what reading indicates that an ohm meter is connected across a large discharge capacitor? So we said if we do that, we use our ohm meter, we connect it into the circuit, and then we see the resistance increasing as the time goes on. That means that there's a capacitor in the circuit. So the answer is increasing resistance with time. Okay. Note the distractor questions, the wrong answers. Okay. So it's increasing resistance with time. Okay. Which instrument is used to measure electric current? So it's current we're measuring, right? So we use an ammeter, right? So we're trying to measure current. Okay. When configured to measure current, how is a multimeter connected to a component? So it's current that we're measuring, current flow. We're trying to get the current in circuit, so therefore it is connected in series, right? So an ammeter or multimeter measuring current is connected in series. Okay, last couple of questions. All right. Which of the following types of solder should not be used for radio and electronic applications? So we said don't use acid core solder. Don't use it. And last question in the question pool. What is the characteristic appearance of a cold tin lead solder joint? The characteristic appearance, if it's a cold solder joint, is it's rough or lumpy. So that's not good. You do not want that. Rough or lumpy surface. So folks, that's the end of the question pool. So let's just go back quickly to the slide deck. Right, here we go. All right, so we were dealing with pages 81 to 89, those who are following in the No Nonsense Guide. This is the contact. If you have any questions, feel free to send a WhatsApp or an email. We'll do our best to get to your questions. Just a reminder, extra information that's not covered in the course, but it could be relevant to you as a budding amateur radio operator. Even if you're experienced, these can be some good tips for you. Please have a look at it. So 1.5 hour practical radio operating tips. Feel free to share it as well. So our next session is going to be next Friday, usual time, 8:30 p.m. So that's Friday, the 14th of July, 2023. So folks, thank you very much for the extra time. Again, we're trying to cover all of the material. Again, continue to be safe, everyone. All the best. Take good care Do have a good night.